Hey everyone! So it's been 2 years since I released the Secure Archlinux tutorial, and I thought it's high time to show you it all again.
とにかくセキュリティが最優先事項。
To be honest, not many things have changed. So if you happen to follow my old video recently, don't worry, you are fine. Secure Archlinux means unified kernel image, fully encrypted system partition, secure boot with your own keys deployed and basic firewall configured. This time I will show you the whole process on my desktop PC where I install Arch alongside my pre-existing Windows deployment. I'll tell you this right now, if you want dual boot, it's just easier to have one drive per system. Additionally, we'll configure BTRFS as our file system. Graphical interface is out of the scope of this tutorial, but I will leave you at the point where you can choose and install any UI with a single command. Remember that this guide has a text version on my GitHub, which is linked in this video description, and I will be following that GitHub in this video. So you can follow it at your own leisure, and if there are any updates, they'll be sure to pop right in this repository.
動けるようになるまで幸せな気分でいなさいね。
First of all, you'll need a USB pen drive for Arch installer. Your hardware needs to support both UEFI and SecureBoot. Optionally, you might need USB adapter for wired networking if, for some reason, your hardware is problematic. I know mine was a few years back when I was making this tutorial. Enter your BIOS and make sure your SecureBoot is disabled. Boot Arch Linux installer from the USB, verify internet connectivity or at least that you have gotten an IP assigned from the DHCP, and let's get to partitioning. I've listed the drives I have on my system using lsblk. As you can see, there's a lot of them. The drive I'm going to install Arch Linux on has some trash from my previous testing runs, so I'll wipe the partition table using wipefs. You need to be extra careful because one mistake here can wipe your entire drive. Also, do not rely on muscle memory because due to various reasons your NVMe name and number may slightly change between reboots. I'm going to use gdisk to create 1 GB EFI partition and allocate the remaining space to the second one. The partition codes don't necessarily matter, but I'm going to keep it clean and use proper ones. I'm formatting the EFI partition as FAT32. lsblk is my most useful command here. I'm using it to make sure I'm using the proper drive name. Next, I'm encrypting the entire other partition using crypt setup, and then I'm opening the encrypted partition using the name cryptlvm. The LVM, while not mandatory, adds a layer of flexibility I like. And by using logical volumes on top of your encrypted partition, you are hiding the system layout. Format the logical volume with your desired file system. I'm going to use BTRFS for a change. I want to stress this and make this super clear. You want ext4, use ext4. You want XFS, use XFS. You'll only need to change a single kernel parameter later on. After all is done, we need to mount the partitions into our file system structure. Here there's only EFI and root partition. So first I'm mounting root under /mnt, and then after manually creating boot directories I am mounting my EFI partition. It seems Pacman now requires some PGP shenanigans, so you have to initialize the queuing first. Pacstrap can perform minimal system installation into specified directory, but in reality you need to add other packages for it to be functional. Different from previous tutorial, I've decided to include Network Manager package as the all-in-one network stack supervisor. It will also integrate better with any graphical interface you decide to use. After Packstrap is done, we can generate fstab and shoot straight into our system. Now everything we do is done as if we were logged as root into our installed system. I will start with setting the root password. After that, I'm installing the manual pages. Installing man is not crucial, but it pretty much verifies that your system has been bootstrapped successfully. And remember, when in doubt, use man. Next, I'm configuring time zone, and if you are doing a dual boot setup with Windows, it's important to know that you will need to change some registry setting in Windows, so that it will store the time in hardware clock using UTC. If you don't do that, every time you switch between systems, your time will be skewed. Now some basic housekeeping, which means locales, keyboard layout and hostname. Finally, I'm creating my non-root user, and I'm adding it to the wheel group so it has access to sudo. You could configure sudo to check for users in sudo group, but the sudo group is not created by default, so you'd have to create it yourself manually. While I'm here, I'm enabling the Network Manager unit and FSStream timer. The Network Manager is pretty self-explanatory, but FSStream timer will by default once a week perform trim operation on your SSDs if you have any. This will ensure you are on top of your SSD performance. Create the script in usr local bin and name it dracat-install.sh. Basically copy what I'm writing and make extra sure you are not making any typos. This script is made to work with accompanied pacman hook that I will write shortly. It will extract kernel version that is being installed or modified by pacman and will call dracat to rebuild the image. One big decision I am making here is that I'm hard coding kernel name to always be bootx64.efi. That means we will not automatically have multiple kernel versions to choose from, but since dracat has a simple syntax, if the need ever arises you can do that by hand. Personally, I've never needed to juggle between kernels, but it's important you know how in case you will ever need it. Next is the script for image removal, but that's way simpler. Make both of those scripts executable and create pacman hook directory. First hook will call our previously written script if it detects kernel being modified. Second hook does the same but launches only when pacman detects kernel removal. Now we need to supply our kernel with runtime parameters. I'm making this easier by first creating a file that contains my system partition UUID. Then in that file, in kernel cmd line variable, I am writing all of my kernel runtime parameters. If you have chosen any other file system, this is the one and only place you need to write it down as rootfs type. Dragup needs two more options configured to be happy. I'm choosing ZSTD as my compression algorithm, and host only being set to no means that every currently available file system module, font, etc. will be included in our kernel image, not only the ones we have currently configured and using in our system. So basically the image will be a bit larger, but it's a way to make sure some extra stuff is also included in case of unexpected circumstances. Finally, execute pacman-S Linux. If you haven't made any typos, pacman will reinstall Linux package containing kernel and fire up hooks that generate startup image. Check your boot EFI Linux directory to make double sure everything is fine and the files have been created. There is only one last thing to do before reboot. You might have noticed I'm not using grub. That means I need to configure my boot entries manually. But compared to proper group configuration, I find it way easier and transparent. UEFI has really made many things easier, even if it works weirdly depending on how the motherboard manufacturer felt that day when implementing the standard. EFI Boot Manager by itself lists currently configured boot entries. You can see here I have some leftover entries from previous Arch installs I've done, so first I'm removing the trash. Configuring the boot entry requires specifying the drive, EFI partition and EFI binary. So as you can see, it's not that complicated. My kernel image will constantly be named bootx64.efi, so it's enough if I make this boot entry only once. Now, after rebooting, Arch should be visible as boot option in the BIOS. Yes, this is how I like to live. If I ever need to switch between systems, I'm just pressing F10 or whatever like crazy during boot. Excuse the really small font. I've used 4K resolution capture card. At this point, I need to enable setup mode for SecureBoot in my BIOS and erase existing keys. Sometimes, just erasing all keys enables the setup mode. On my motherboard, however, the process is a bit convoluted and the keys needed to be deleted in a specific way, otherwise the BIOS menu completely froze. After that's done, I'm back in the Arch instance. I need to install sbctl to cover all of my SecureBoot needs. Calling sbctl status shows my current situation. If yours does not look like mine, you need to play with BIOS a bit more. Take a minute to read any warnings, as in my case SBCTL also pointed me to a GitHub page that told me what I needed to fix in order for the SecureBoot to work properly. After I've confirmed the basics, I'm generating my keys and sign my EFI image. I also needed to configure the Dracat so it knows where the keys are located. Now Dracat will sign our generated image by default, but SBCTL has its own pacman hook that will try to sign non-existing files and will generate errors. My solution to this is to create another hook that will overshadow SBCTL's. It's not ideal, but hey, it works. All that's left is to enroll our keys into UEFI firmware. If you add Microsoft as a parameter, it will also enroll Microsoft keys, in my case allowing Windows to boot. Now that I think about it, you might as well just remove SBCTL after enrolling the keys, but I haven't tried that to be honest. Reboot and enable SecureBoot in the BIOS. I haven't done that in the video, but you should also enable BIOS passwords so that no one can turn the SecureBoot option off. You are almost done. I've also promised you a firewall. This video is getting long enough though, so I'll save the lecture for later, but for now you need to know that this firewall assumes you will not be using Docker. Docker supports and requires legacy IP tables solution, but I wanted to show you NF tables, its successor, as it streamlines a lot. Also remember that ports exposed by Docker are not blocked even if you set input to drop. You definitely need to read Docker documentation in order to find out more. Anyway, typical workstation firewall should block all incoming traffic and only allow connections you yourself have established from within the system. It should also enable traffic on the loopback interface. nftables keeps its rules in etc/nftables.conf, so you can copy what I'm showing you if you want the same behavior I just described. At this point you can choose and install whatever UI you want. In the previous tutorials I've shown you Sway and GNOME, so this time let's install KDE Plasma. Yes, you can also install Hyperland. For Plasma I'm going with all the default suggestions. Plasma comes with application menu that installs everything via Flatpaks, and from my short experience it works quite well. Since I'm not using any login manager and Plasma doesn't auto-configure one in the meta package, I need this simple script that will launch the UI. Congratulations if you managed to perform the whole system installation. You can adapt the system further depending on your needs. If you want Grub, you can install Grub. At this point you're pretty much aware of hooks, scripts and other things in your system that generate kernel image, so customizing it further can be an interesting experience. At this point you can choose and install whatever UI you want with pretty much a single command. Plasma, GNOME, Sway, pick your poison. There are some things I haven't touched in this video, like BTRFS snapshots or NVIDIA drivers for my GPU, but I'll save that for my next material. Next time, Arch Linux for gaming.